Swayam Prabha. Digital India. Educated India.
So we saw so far that if we go for a full sensor based approach, dedicated sensor based approach, then there is a problem of the scalability, right? So let me just write it down for you. So if you're going ahead, with the sensor, then dedicated sensors, they will require, you will face a problem of a scalability. And if you are going sensor less, then you will have a problem of accuracy. So maybe the accuracy, you are somehow making a trade-off with the accuracy, sensorless, right? So now, so there could be a possible solution where which we are calling it as a sensor light solution. So sensor light solution means we are going to use the scalable sensors whenever it is feasible, such as, for example, cameras and the microphones. They are very, very widely available sensors which can allow you to capture the audio visual modalities and only the audio modalities, and that is one approach. And then at the same time, what we can do, the non-scalable sensors can be replaced with the scalable proxies. So for example, if you're trying to make use of camera, can be very good option here. And for example, because once that it is already available in most of the laptops. Similarly, for example, it can be purchased at very, very low costs, and previous research has already shown, we have talked about it, that you can use the camera as well to, for example, record and monitor the heart rate and the heart rate variability and related features. So this seems like an excellent solution. And other thing, for example, that you can do, you can also simply look at the webcam data and you can apply the motion tracking techniques on it. So for example, you can do the posture analysis, gesture analysis, all with the help of the 2D visual data. Of course, you will need to work a bit more on the software side, but working on the software side is a bit more easier. It's more accessible than working on the hardware and trying to make the hardware scale. So that for in this way, like that is one type of possible solutions. Other, we already talked about that, like the camera can not only be used to monitor the heart rate and the heart rate variability, it can also be used to monitor the gaze patterns of the eyes, and hence it can also replace to certain extent the eye tracking devices and the sensors that we have. So that is the conclusion of this thing. If you have the possibility of going making use of the dedicated sensors, go ahead. Many times your application domain will not allow it, then you may want to use the existing sensors which are there available in the system to track the behavioral data, or for example, you may want to replace the dedicated sensors with the sensor proxies, and hopefully it may work wonders for you. Okay. Sorry. So that was about the sensor and what to do with the sensors that are available to us. Now let us talk about the accuracy as well. So in general, there is we know that the naturalistic affective detection has seen a lot of research and it has been improved a lot. But of course, there are lots of problems that are associated still with the affective computing domain and in general the research and the development that is there. One thing we already talked about it, there most of the time the sensors that we require, they are intrusive. Many times it could be expensive as well. Many times it could be noisy as well, and more importantly, they are not scalable. Other thing that we see that technical challenge. If you talk about the technical challenges, then the detection itself can suffer from the weak signals that are embedded in the noisy channels. So many times, for example, you are trying to look at a particular data, and then but that data itself is surrounded by lots of noise around it. For example, maybe you are trying to capture the emotions in the voice. As simple as that. You are trying to capture the emotions that are there in the audio modalities of a user, but now we are no more in a lab setting. We are in a naturalistic setting where there is a lot of noise around it, and hence your target user's voice data is getting embodied, is getting surrounded by lots of noises that are around there, and hence it really becomes very, very challenging to segregate that data of the user, voice of the user, and do some analysis on the top of it. One thing also that we have seen, even though we did not talk about a lot in detail about the machine learning and the deep learning algorithms itself, but most of the time what we want to do whenever we are talking about the affective computing, it is going to rely heavily on the machine learning and the deep learning algorithms. And whenever we talk about the machine learning and the deep learning algorithms, it's no surprise that they need a lot of adequate and realistic training data in order to make a lot of sense. And many times what happens that emotions, data associated with the emotions may be very, very difficult to even capture, to annotate, and hence in turn our machine learning and the deep learning models may suffer and their accuracies may suffer. So other thing, for example, that may happen, that whenever we are talking about the affective computing, most of the time we are just looking at the transient emotions. But now if you want to incorporate the context and the appraisals as well into it, then this becomes a bit troublesome, because if you want to incorporate the context and the appraisals, and let's say the user's beliefs, desires and intentions around it, then it can become very tricky, because then you will have to be able to track lots of different things, and which may be very, very difficult here. In general, whenever we are talking about the affective computing, also there is a common mistake that the researchers do, that the developers in the community do, and they are doing that many times. They are taking using one for the another and another for the one. So for example, whenever they are talking about the model of the emotions, they are not able to discriminate properly between the categorical models or the continuous models. Similarly, for example, many times the mood versus emotions is not being differentiated. So you may refer to mood, which is long term emotions, or maybe you are referring as the transient emotions, but you are just using the one for the another, and hence you are not able to differentiate these things, and hence there is a lack of clarity on your side. Nevertheless, even after this, if you are able to do some recognition and you are able to make use of some monitoring, then what happens, that the generalizability itself, it becomes a big issue. And generalizability in general for the machine learning and deep learning algorithms itself is a problem, but more so with respect to the emotions and the affective computing, it's a bigger problem, because you may want to look into the individual variability. We talked about this. You may want to look at the cultural variability, cultural differences. For example, the death of an individual, at the time of the death of an individual, the way it is being expressed in Indian communities is very, very different from the way it is being expressed, the lamentation or the sorrow that is being expressed in the outside community. So of course there are lots of cultural differences that are surrounding it. Of course then context, time, etc., they also play a lot of role, and so generalizability becomes a big issue on especially when you talk about the affective computing models. So the question that in general we want to ask now is this, that okay, what type of accuracy, or to what extent an accuracy is a good accuracy with which we can go ahead and deploy the system and we can make it work. So in general, we already saw that affect detection itself is a very tricky problem, and we can very confidently say that okay, it's going to be very, very unlikely that very soon we are going to have a perfect affect detectors, that are not only able to do 100% classification of the emotions of a user in real time, but also they are able to generalize well to the new individuals, to the interactional context, and in very noisy situations that are around us. So it is not going to happen anytime very soon. It will require lots of advancements, not only on the hardware side, but also on the software and the machine learning and the deep learning side from us. So the idea is, okay, when should we start taking the information that we are getting from the emotion recognition systems and build on the systems that can adapt to it, or in general when we want to close the loop. So there could be two possibilities now, whether we can go wait until there is a perfect affect detection system in order to build the adaptive system on the top of it, which is going to work perfectly fine. Or we can just go for a not so perfect affect detection system, and we can try to make it work. So the thing is here, since it's a very tricky problem, it may take a lot of time and resources to arrive to that situation. So even if we are able to get a moderate degree of recognition accuracy, and what is a moderate degree of recognition accuracy for the emotions, that depends on the situation to situation and domain to domain and as per use cases. We will talk a bit more about it. But the moment we are able to get, or you are able to get, a moderate degree of recognition accuracy, we believe that should be sufficient to create the affect aware interventions. So affect aware intervention means adaptive interventions. We just saw about some of the examples, some of them. But of course, we have to take into account the fact that they should be fail soft. Fail soft in the sense that they should not do any harm. Let's say even if they are doing some adaptation which is based on the incorrect classification. So that is a very tricky suggestion that you want to look into it. And of course, now for example, when we say that the moderate degree of recognition, and then accordingly the severity of the interventions. So of course, you want to make an adaptive system, but since you are making an adaptive system which is not entirely perfect, which is based on not so perfect affect detection systems, so you may not want to put a lot of hard confidence in the severity of the interventions. So you may want to take it with a pinch of salt, that okay, I got a particular classification, I got a particular emotional state of a user based on whatever sensors or the models or the software that I have deployed, and there is a possibility that it may not be so correct. Hence, the adaptation that I am going to do is going to be accordingly very not so severe, and could be a moderate, and then it can be calibrated to the extent that I am able to put the confidence in my detection accuracy. So for example, imagine I can come in my particular use case, I am able to make use of the dedicated sensors, dedicated hardwares, and I am able to use state of the art algorithms, and then I know the detection accuracy is good, or is almost perfect in my case. So then maybe you can put more confidence in the system, and accordingly the adaptations that you are making, maybe you can put more confidence in the adaptations as well, and then accordingly so on and so forth, right? So this is a very good important thing to understand, that you need to take into account the system that you are building, and then the use case that you are building, and accordingly you need to define that okay, what could be a moderate degree of recognition for you, what could be the severity of the interventions that you want to go ahead. But bottom line is, you may never want to wait for a perfect affect detection system in order to start building a adaptive system. Okay, so that I hope is a bit clear. Now, having talked about okay, the sensors, having talked about that what is a good accuracy, what accuracy is good enough. Now let us talk about a bit on the adaptiveness, right? So the question that we want to answer, okay, what should be the adaptiveness of the system? And this is a very tricky question again, and the severity of the adaptive interventions, as we said, already is determined on the basis of the confidence that you are able to put into the system. But let us see what are the different levels of the adaptation that we can have in the system. To begin with, for no surprise, we can have a level 0 adaptation, which we also call it as a no adaptation at all. So in the no adaptation at all, what it means that we do not expect the system to alter its behavior in response to the emotional state. As simple as that, whatever is going to be the emotional state, we are going to monitor it, but we are not going to do anything about it. We are simply going to take that information, for some other analysis purposes, but we are not going to let the system's behavior altered by the response in response to the emotional state. And that is what is happening for most of the systems that we have. And for this, what happens, a predefined interaction scripts mostly, is used for the machines, for the services that we use. We just talked about the gaming examples. So, when you are sad, the non-playing characters are also around, they show a sadness, but all this is very pre-defined script, and it does not really know, first thing, it does not really know that what your emotion is, and even if it knows, it decides not to do anything about it. So this type of system is where there is no adaptation as all happening, and most of the machines that we are happening interacting with the today, or the services, including, for example, the voice agents such as Alexa, Siri, most of the machines are like that. Their adaptation is not based on our emotional state, and many times our emotional state is also not being monitored. So that is the level 0. Then comes the level 1. So the level 1 is basically, what it does, it tries to monitor your emotional state, number 1, and then it also tries to recognize that, okay, there is a need for the adaptation at a particular time. So it tries to identify the time of the intervention or the need for the intervention. But of course, it just does that. It simply tries to identifies that, okay, there is a need for the adaptation, but it does not perform any adaptations at all. And for example, of course, how will we identify that, okay, now there is a need for the adaptation? It could be on the basis of many different metrics, and some metrics, some indicators could be like this. For example, the system is able to, system or the service that you are interacting with is able to understand that, okay, you are experiencing a negative emotional state because of your voice or through any different modality, and now it knows that, okay, since you are experiencing a negative emotional state, you are feeling low, you are feeling sad, you are feeling bored, and so on and so forth. So what it means that, okay, there is a need for the adaptation here. Similarly, whenever there is a change in the emotional state, maybe you can just look at this metric. The systems can look at this metric, that whenever there is a change in the emotional state of a user, maybe the system also needs to adapt to that. And that is the metric that of course, you are not doing the adaptation, as we already talked about it, that no adaptation is being performed at this stage, but you are able to identify the need for the adaptation. Negative emotional state, we already talked about it. Changes in the emotional state, whenever you change your emotional, let's say, from one to another, maybe you were feeling happy and suddenly you started feeling sad. So then maybe the system will get an alert, oh, the individual was feeling happy and now the individual is feeling sad. There is a change in the emotional state, and maybe this is a right moment to do some adaptation. But in the level 1, of course, no adaptation is going to do. And then you can think about like lots of other different metrics. I will let you explore and think that what could be the other metrics on the basis of which you may want to do some interventions or adaptations, right? And so that is the level 1 system. So level 0, no adaptation. Level 1, it just recognizes the need for the adaptation, but in general, there is no adaptation. As of now, yet we are not doing any adaptation. Okay, so now we go to the level 2, which is a bit more fascinating, which is the single task adaptation. So single task adaptation means what? What it does, a single task that is being performed during the entire cycle is adapted over time to optimize a particular metric. So we already have some metric using which we are saying that, okay, we are tracking the emotional state of the user. We also have a metric or indicator which is telling us that we are recognizing the need for the adaptation, and then we are also in the level 2, now on the top of it, we are also doing the adaptation in a single task. And this adaptation can be, we may want to look into that, okay, what is the metric that we really want to improve in terms of the performance metric, and how can be it improved by doing a particular type of adaptation. Just to make example very clear, for example, maybe you are looking at, let's say your aim that, okay, you are building a conversational AI agent, and then your aim is to make the user happy. So at the end of this interaction, the user should be feeling happy, user should remain happy, user should feel happy about the interaction once the interaction is over. So whenever the user, you are monitoring the emotional state of the user, and whenever you see that, okay, whenever you experience that, okay, user is feeling a bit low, then what you want to do, you may want to do certain type of adaptation which will make the user happy, because your aim was to make the user happy, and so you will do a particular type of adaptation that is going to make the user happy. Similarly, for example, if you talk about the affective learning systems. So where your aim is to improve the learning, then you maybe what you want to do, you are tracking the emotional state of the user, and your continuous aim is to keep the user engaged or keep the boredom of the user as low as possible, and so on and so forth. So then accordingly, the type of the adaptation that you would like to do will be to address that particular goal. Maybe you want to make the user happy, maybe you want to make the user engaged, maybe you want to make the user's boredom low, and so on and so forth. So I hope that this is what it is clear, that you are able to adapt with respect to the performance metric that you have kept as a goal for yourself. And many times this adaptation, it itself, what kind of adaptations could be there? It could be the result of some predefined behavior. So you are saying that, okay, my user is feeling sad, I am going to make the user happy, but what will I do to make my user happy? Now this is the question. And this particular type of behavior in this particular system, in the level 2 system, is the result of a predefined behavior. So for example, we already looked at the example of the shimmy robot. So in the case of the shimmy robot, for example, what happened that the shimmy robot was able to play some music as per the emotional state of the user, but this particular type of music or the behavior of the gesture of the robot was predefined by the script that the developers have already built in. Similarly, adaptation can also be the result of the accumulated experience or the learning that happens over the period of time. So for example, while it is not happening to the extent that we want it to be done, but in the intelligent tutoring systems, what can happen that you may that the entire experience of the user, say, interaction with the system over a period of time, and then you can learn from that particular experience, and you are able to adapt on the basis of that. And then for example, what type of adaptation will work for this particular guy. So a very simple example is when, for example, as a teacher, when the teacher is taking a class in the for certain students, then teacher knows by the time. In the beginning, maybe the teacher may not have a very good idea that how should I teach a particular topic to a particular student in order to make him or her understand. But over the period of time, the teacher knows, a good teacher at least knows that, okay, I need to address this particular problem of this particular student in such a way so that it helps that particular student in a specific way. So the type of the adaptation that the teacher does for a specific student is different that it does for the other student, and this is the result of the learning the teacher has done over the period of time. And this is what we are envisioning here, that if the system can learn from the accumulated experience of interaction with the users, then it can improve it can create it can does the adaptation not on the basis of some predefined behavior, but on the basis of the learning that it is doing, and it is going to be very, very adaptive and personalized. So that is the level 2 adaptation, which is a single task adaptation, and of course keeping a particular performance metric in the mind. Now level 3 is the next level adaptation. In the level 3, what happens that rather than doing the adaptation in a single task, where for example maybe in the case of the shimmy robot, maybe the robot was only able to do the adaptation in its voice, or maybe was only able to do the adaptation in its gesture. Now we are talking about that set of different tasks that are happening during the process cycle can be adapted over the time in response to optimize a particular performance metric. And this adaptation can be of many different types. So for example, adaptations could be that there are multiple tasks that the agents are doing, that your machines are doing, that your services are doing. You can simply do the reordering of the tasks, or you can simply do the adaptation of the individual tasks that are happening but in parallel. So for example, a good example of this thing would be that if you want to say that, okay, you want to do the reordering of the tasks based on adaptation. Maybe for example, you are trying to create an intelligent tutoring system here, and the tutoring system, the moment, for example, the user logged in to learn a particular concept, maybe the system felt, okay, the individual looks a bit low on the energy today. So if the individual looks a bit low on the energy, I am going to teach maybe topics that are easy to follow first, rather than start with the hard topics. And maybe I am going to teach in a way that is at a very, very basic level. For example, multiple ways that this type of adaptations are being done. and so you are reordering also, and the multiple tasks are being taken into account. So you are looking at, you are not only adapting your teaching style, you are also changing the content that you want to teach, for example. Or in the other way, you are simply adapting multiple tasks, but you are not doing any reordering of that. For example, imagine that you are interacting with a chat bot, a conversational bot, and the conversational agent is not doing the reordering of anything. It's following the order that it's supposed to follow, but maybe it is not only adapting its gestures in response to your emotional state, but also it is adapting its voice as well in response to your emotional state. So there are two tasks at least, and maybe on the top of it, maybe the task that it is supposed to perform, actually maybe you have a problem with the bank or something like that, it is also able to do it in a way that really pleases you. So there are lots of different tasks that are happening, lots of different processes that are happening, and the adaptation of all these processes or multiple processes are happening at the same time in this level 3 type of adaptation. And of course, nevertheless, no matter whether you are adapting a single task, multiple tasks, whether you are reordering the tasks, whatever the type of the adaptation, all the adaptation has to keep in mind the performance of the system. So basically you have a particular goal in mind, you want to make the user happy, you want to make the user feel fulfilled, you want to improve the learning of the user, whatever. You have already all these goal predefined, and all these adaptations are happening as per the broader goal that you have set for your system, right? And in this case, of course, rather than having a predefined script, what you simply have adaptation that is the result of the accumulated experience. So it's very, very personalized and very, very customized for each different user. So the adaptations are going to be different for each different user depending upon their likes and dislikes. So that's quite interesting. Now, in the level 4 adaptation, it's very much like the level 3, but there is a critical difference, that the process of the adaptation is carried out between multiple independent agents. So what happens that till level 3 we are assuming that we have a system or a service or a machine where there is only one agent with which we are interacting with, and that agent is adapting to our task, or is not adapting, or is adapting multiple tasks that the agent itself is performing. Here we are saying that we are interacting in the multi-agent setting, or we are interacting with the multiple services at the same time, and all these multiple services, multiple agents, they are talking to each other, and they are saying that, okay, like you adapt this, and I will adapt this, and let us collectively make the user feel good about the entire thing. So for example, maybe you are playing a game, and in the game there are multiple characters. So when there are multiple characters, rather than one character adapting to you, all the different characters, they are adapting to you, but they are doing in sync by communicating with each other. So this is really fascinating, because now your user experience is being looked at holistically and comprehensively, and maybe it can provide a better experience overall. And while doing so, of course, what the agents can they can communicate the different adaptations, and they can be applied individually within each agent. So as I said, agent A can say to agent B, service A can say to service B that we have to do this, and service A will do this type of adaptation, service B will do this type of adaptation. Similarly, agent A, agent B, machine A, machine B, or whatever different types of things. So for example, there are different let's say in the gaming itself, there are two different characters that are around you. They are supposed to be helping you in, I don't know, finding some treasure. And then so agent A is going to maybe say that, okay, maybe the user is not able to find it, let us help the user find it. So agent will say, okay, maybe I'm going to clear the path for the user, while let's say you take care of the, I don't know, enemies that are there on the path. So different things, right? So different, of course, depending upon the capabilities of the agents or the services. And as I said again, the creativity is the only limit here again for you on the type of the adaptations that you can do for your machine. Okay, so again, when we are talking about these multiple agents can be both real and simulated, and of different types as well. So we are talking about the agents in the games. We can also have one agent in the embodied agent, in the animated agent, one robotic agent, and so on and so forth. So basically, all the different types of agents or the services that we can envision, they can work together. Imagine you have a robot at your home, you have a Alexa also, you have a Siri also, and they all are talking to each other in order to make you feel happy. I mean, that would be really nice, for example. So that is what is known as the communicated task adaptation. Now in conclusion, when we looked at the, so this is the, let us look at the conclusion now. So when we looked at the open issues here, we already saw that we can use the scalable sensors whenever there is a feasibility of it, such as in the case of the cameras and the microphones, and we can also replace the non-scalable sensors with the scalable proxies, which can look at the latent behavior, such as behavioral data, the one that we, for example, the way we capture it from the keyboard typing and so on and so forth. Camera is a very ideal choice because it's already available in all the laptops systems, and if not, then it can be also purchased at very low costs. Motion tracking techniques can be applied to the video data, hence like it can also enable do this kind of tracking. And so this is these are some of the things that you want to look into when you are looking at the conclusion.